The Anets had a larger build area, a 220 by 220 versus the 180 by 180 on the Kingroon. So I was able to print more parts in a single run on the Anet and also larger parts. That's why it is a little bit higher on my list, or I rated it as my best printer for the print farm. However, I did note that the Kingroon KP3s are the most reliable. I rely on them a lot. The ones in my office do all the prototype work, and a lot of times when I have new parts and I want to do a limited production run, I'll come up here and put them on these KP3s, and I'm getting ready to set these up now, and they make a lot of the parts, like this 3-port extension adapter and also the Dremel tool holder, or the round tool holder as we call it. And it's time to check the alignment on all of these printers. So I'm up here tonight. It's Friday night, and I'm going to go down and check each printer, check the bed leveling on them, the Z-axis offset, and so forth, just to make sure they're in top-notch shape, because I'm going to be running some new parts, and I want to make several of these parts on the Kingroon up here. And these new parts that I have for the helping hand are actually multiple pieces that fit together. So I have to know that my CAD drawing dimensions and everything for the different parts, once that's translated to the slicer and to these printers, is going to allow these parts to fit together properly. And if they don't, I may have to go back and make some adjustments to the CAD drawings to make them compatible. But once I get them to where they can run up here, where I'm printing 2 or 3 at a time of each part and then testing them, then I'll be ready to take them down to the new print farm, put them on some of the Anets or Tronixies, and go ahead and print a batch of 50 or 40 or 100 of them, whatever I need, because I can get a lot more capacity down there. But I thought I'd go ahead. I had the camera up here, and before I started working on these, I powered them up, so it's probably a little bit noisy. But I thought I would go ahead and do a video. I haven't gotten one out this week, and let you know what I'm doing up here. I do have a KP3S now. I purchased one, and it's been printing almost non-stop in my office. And I have an order in for some more of the KP3S. It is a good printer. I like it. It has a few advantages over the KP3. I haven't determined yet how much better it is. A couple of things. It has the control panel on the side here, which is good, because this control panel, if the printer's operating and the printing out in this area, it's hard to get under there and select one of these buttons where you can adjust the temperature or something. And I do like that, with being able to, especially in the early stages of printing a part and using different filaments, I like to be able to adjust the temperature on the fly and see how it goes. And since we're talking about temperature, let me mention one thing that I found out. When you have a filament that gives you a temperature range of 190 degrees Celsius to 220 degrees Celsius, you can probably set that up to print at 200 degrees or 205 degrees, and it may print fine and you may get a good print. However, one thing I'll caution you about that I've found out is that even though the print looks good and it prints well and quality looks good, when you go to put it through a stress test, I've found that if I can print at a higher temperature and still get the same quality, I get a stronger part. And so what I'll do, I'll go ahead and push it from 200 degrees up to 210 degrees or 215. And anytime I can print at a higher temperature and still get good quality and not have any problems with the print, I tend to go, especially with PLA, I tend to go with the higher temperature. And the reason for that is that when you're laying down your layers, your different layers of filament, when you go from that 21st layer to the 22nd layer, for example, that 22nd layer, the hotter that filament is when it goes down, the more it's going to fuse in to the previous layer, and the stronger those layers are going to be connected. And when you're printing a part vertically, that's when you have the tendency for the part to break in the horizontal plane, because it's breaking usually, and it's a clean break across one or two layers, because the layers weren't fused together completely or as well as they could. And this is the same thing that happens on your first layer on the bed. When you put that first layer down, you want it to flatten out and adhere to the bed real well. But don't forget about all the additional layers going on top of that. They need to lay down pretty well onto the previous layer, and it needs to, that filament coming out of that nozzle needs to be hot enough, that first fraction of a second that it hits the previous layer, it needs to be hot enough to give it a good connection there and fusing the layers together. So that's something I found that helps me add a little bit of strength to the parts. And anytime I can go to a little higher temperature, I kind of push it up to that higher limit. And you'll be able to tell from your print quality and everything when you're pushing the temperature too far, especially on the PLA. Another thing too, on these printers, there's been a lot of talk. It came up with the Anet printers that I have. I had some comments where people were saying, oh, they heard that Anets had a problem and they could start a fire and so forth. And I don't really know. I heard the story that somebody had a fire on one of the old acrylic Anet printers years ago, and that it burnt down their house or garage or something. You know, who knows? You hear stories all the time, and I hear stories now and where they're saying that the Anets are a fire hazard. They even said that there were mentioned a lot of things negative about the Kingroon printers and the power supply and the power connectors and different things like that. And I've worked with electronics most of my life, and I've done some checking on a few things, and I really don't see any problem at all. Just because one of the power connectors that they were talking about was this power connector right here that the KP3 uses. And I think I saw a video one time where somebody claimed that it wasn't rated to carry the amperage and the power required for this printer. But the fact is that it carries the power fine. I haven't heard anything about anyone having any problems with the KP3s and the power. I've checked mine. I've made a point to check these connectors. And you don't have to have, just because it appears to be a small connector, it can carry a lot of amperage just look inside of a glass 10 amp fuse and see how small the wire is in there for a 10 amp fuse, and look at circuit boards and the little thin layer of copper on some of those boards. Obviously, when you're getting into the 110 volt areas of a circuit board, or the 12 volt power coming in and so forth, they make those wider so they can carry some more current. And also remember that when you're dealing with a 24 volt power supply, like the Anets and the KP3s, you're using half the amperage, and the amperage is what determines the wire size requirement. And it's the same thing with any kind of power, even AC. You see these transmission lines from the power plants that go to substations. They transmit power on wires that are not very big around. They may be a couple, a few inches in diameter, which sounds like a big wire, but really it's not that large a wire, but they're carrying hundreds of thousands of volts through those wires. And the higher the voltage, the less current required to get the same amount of power transmitted through a line to a substation. And then once it's there, it's converted, and that's why you have a transformer at your house, because they're still taking thousands of volts and dropping it down to 110 or 220 or whatever. So a little bit about power. If you have a 24 volt power supply, that's good, because you can get a little bit more power to your printer through the cable and not have to worry about problems there. Okay, another thing is your build plate or your build surface. And some people have commented because they see me putting my hands on these surfaces and everything. But believe me, I have alcohol all over the place. And when I get ready to run some production prints and stuff, I'll clean these surfaces. And even these magnetic surfaces here need to be cleaned with alcohol. Every once in a while you take your scraper and you remove any of the filament left on there, and then take a towel and just a light rubbing with alcohol. Now, on certain surfaces, be careful. Do not use, I have some 99.9% alcohol. I have some 90% alcohol, some 70% alcohol, and I think some 40 or something percent alcohol. Now, I'll use the 99.9 on the glass beds and some of the surfaces, but on the PEI and on some of these other surfaces, and especially the glass beds that have the coating, the textured coatings on them and so forth, use a lower percent, like a 40 or 50% alcohol when you do that. And don't rub real hard, just do a light wipe and let it evaporate. You don't go back and dry it off or anything. It's not necessary. Some of the stronger alcohol can actually start dissolving some of the surfaces if you put too much on there or rub a little hard with it or use too strong a mixture. Another thing, the KP3S. One of the big things about it, and I probably should have brought it up here, set it against one of these KP3s. The KP3s, the Ender 3, most of these printers have the extruder fixed over here, and then the head and the hot end move freely. And my thinking originally was, Well, that's probably a pretty good idea, because you don't have that big old heavy servo motor there, and the extruder and all that extra weight going back and forth and having to be pulled back and forth by this belt. I figured that extra weight, the momentum of it, would cause some overrun in each direction, especially at higher speeds. However, once I've used the direct drive, and I have some other printers here that do have direct drive also, there's an advantage. Most of them don't seem to have a problem with the additional weight going back and forth. They can handle that. But the biggest advantage when you have that direct drive, you're putting that filament in, and your retraction works a lot better, because there isn't the little bit of slack that you get through the tube, and it allows it to respond quicker. And the same thing with the extrusion itself. If the extruder starts to back up a little bit, the direct drive is going to push the filament on through and keep the flow going better. So you can, that's one of the advantages of the direct drive. And so far I haven't seen a disadvantage that I thought I might see with some of the back and forth motion and the momentum of that extra weight going back and forth across that x-axis. So I'll be keeping an eye on that, and I'll be doing some tests to see if I'm getting any overrun, and where it would show up would probably be on the sides of the part, where you start seeing a little bit of a ripple there where it overruns a little bit. Or at least that's what I think I would expect to see. But that's one thing to watch out for. But other than that, I do like the direct drive for the other reasons I mentioned. And cooling. On almost every one of these printers, the cooling is coming from a single fan, and it's going to one side of the nozzle. I have a few reservations about that, depending on the travel direction of your print head. That nozzle, as it's laying down a bead, if all of the cool air is coming from the right side, when the nozzle's moving to the right side, the bead is going to be following the nozzle, and the nozzle will deflect the cool air coming from the fan. And then when it gets to the end and starts going back to the left side, the bead of filament coming out of the nozzle will be getting the direct blast of the cooling air. So that means that as you lay down a bead going to the right, the bead takes longer to cool. But when it's going to the left, it's cooled much faster because it's getting direct air on it. Okay, what does this do? That means that every other line of filament is going to be cooling at a different temperature. I don't know. I'm not sure how that is going to affect the quality of the print. I'd have to do a lot more research on it, but it is something that I'm aware of, that I'm looking at, and I know a lot of people have come out with circular cooling devices that will bring air in from all directions around the nozzle to give an equal amount of cooling no matter what direction the nozzle is moving in as it's laying down a bead. And I have developed one of those for the Anets and for the Ender 3, and I'll be testing it. I've been doing a little testing and printing and design work but I should have it ready to go here in a few weeks. As soon as I get it ready, I'll try it out on some of the printers, and we'll do some comparison prints with and without it on the same identical printer with everything identical. And I'll see if I can push those printers to the limit so that I can see if they do a little bit better with that controlled cooling. So that's one of the things on the plate. If it does work and does good, I'll throw those on the website so those of you out there with Ender 3s or Anets can use them. I have been working with my grandson. He's been doing a lot of soldering for me and so forth. And we take these we purchase these power connectors like this, and then we add another connector to the other end and put the corrugated tubing on and heat shrink the ends. And this is just a little power jumper that goes from the helping hand powered head to some of the attachments that require power from that power head. He's been soldering these together, and I think in an earlier video I showed him soldering, and you could see the smoke coming up from the rosin, and that's not good and healthy to breathe that stuff. I've come up with an attachment for the helping hand. It's a fan that's an exhaust fan that will draw those fumes away and actually run them through a filter and just give you a cleaner environment. And then I can reverse that filter and use it as a cooling fan or a drying fan for people that are using the helping hand to paint little miniature soldiers or people or miniature animals, whatever, or small model trains, N-gauge, or airplanes, whatever. And they want, as they paint, they want that paint to cool as quickly as possible so they can keep painting. It will allow some cool air to blow on those things to help dry that paint, but that air is coming through a filter so it won't be picking up lint or little hair or fibers in the air and blowing them onto the paint. They'll actually be blowing filtered air onto that painted surface and keeping any other particles in the air from landing on it until that paint's dry. Same thing with glue, helping glue dry. It can be used for that. And like I said, in the exhaust mode, the next time my grandson's soldering over here, you don't have to worry about him breathing the fumes, because I have the exhaust version of it set up to where, like I said, it will draw those fumes away from him. So until the next time, happy printing from New Tech Inventors.